answers to the examples 1 through 4 in your packet that I handed out. So, example 1A. 9 of the functions have a domain. Domain means what?
Where they go.
Like how far they domain or range. I mean X or Y.
Where are they go?
Domain is the X. 9 of them have a set of all real numbers. Which 3 do not? Somebody raise your hand. Tell me. I'm gonna just okay. I'll start with Grace Ann's group, then we're going around the room. You give me all 3.
The reciprocal function, the square root function, and the natural logarithm.
All right. Reciprocal, square root, and natural log. Does anybody not understand why any of those do not have a domain, all real numbers? This one doesn't have 0. This one doesn't have negative numbers. And this one doesn't have 0 or anything negative. All right, B. We're going to go to Amy's group. One of the functions has domain the set of all real numbers except 0. Which function is it? Yeah, 1 over x. And why would it have all real numbers except 0? X cannot be 0 in the denominator. All right, very good. Now, Sophie's group, C. Which 2 functions have no negative numbers in their domain?
Square root.
Okay.
I don't know. We only have square root.
Okay.
Sounds like
Melanie?
hydraulics.
Melanie?
Natural log.
Natural log. Look up here. Do y'all see that this one is all positive x's? Okay. Now it says of these 2, which one is defined at 0? Caleb's group. Square root. It's the only one that has 0 in its domain.
Yeah.
All right. Example 2. Looking for continuity. Okay. Only 2 of the 12 functions have points of discontinuity. All right. Emma McCartney, y'all's group. Which 2 are discontinuous?
Reciprocal and the greatest integer.
That's right. Reciprocal and greatest integer. Very good. And then the next question is, are these points in the domain of the function?
Still less.
No, that's going to be Melanie and Grace Ann.
The greatest integer is yes, and the reciprocal is no.
Okay, so it says only 2 of the 12 functions have points of discontinuity. Are these points in the domain? Greatest integer, yes, because the points are in the domain. The other one, no. Okay. Now, example 3, looking for boundedness. Only 3 of the 12 basic functions are bounded above and below. Which 3? All right, Amy's group.
Well, we got absolute value, squaring, and square root.
Okay, now, let's talk about bounded. Bounded would mean that it bounces between something here and something here. It goes bounce, 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 bounce. Somehow, it doesn't go above this and it doesn't go below that. So let's rethink. Sine would be 1. Very good.
Cosine.
Yep. And logistic, yes. So let me write that. 1 over 1 plus e to the negative x. All right, very good. And example 4, looking for symmetry. 3 of the 12 functions are even. Okay. Can Emma's group tell me any of them or all of them?
We had absolute value, squaring, and cosine.
Absolute value, squaring, and cosine. Very good. Even means that it can be folded along the y-axis and it's perfectly symmetrical. So any questions about those? All right, so we're going to keep on. Let's look at the next part, and I'm going to work through these with you. We only have a few minutes, so I'm going to go through these quickly. All right, I'm just going to go through examples 5, 6, and 7. Examples 5, 6, and 7. So y'all need to pay attention. All right, we're going to analyze this graph. It looks more like absolute value than. Okay, sorry about it. Not a very good parabola. All right, now on the interval. Now I want y'all to circle increasing and decreasing. Circle the words increasing and decreasing, and tell yourself that you use the X values. Caleb, unless you pricked your finger, that didn't make a mark. He's circling with his finger over there. I'm just like.
Oh my God, maybe she won't notice.
Prick your finger and
I didn't want to get my pencil back out, man.
Okay, so increasing and decreasing, you use X values. Max and min, we use Y. All right, everybody look up here. If I'm about to draw this graph, what am I doing from here to here? Decreasing. So I'm going to write that it's decreasing from where on the X? Where on the X? Negative infinity, and it's stopping at 2. Does it include 2? Yes. Okay. Now, from here to here, what am I doing? The green part. Increasing. And where did I start the increase on the X? 2, and I'm going to positive infinity. So that's increasing and decreasing. So all you're doing is where is it going down, where is it going up? There is, sometimes they'll ask you if there's a constant, like where is it constant? B part, is this function odd, even, or neither? Neither. Remember, even was symmetrical about the y. Odd would look something like this, or this, where it's symmetrical in 1 and 3 or 2 and 4.
Can you still do if it makes an N if you draw 2 lines? Because that's what Miss Roberts taught us.
No.
If you draw lines and you can
I
make
thought
an
that was a
N.
negative. I thought that was negative slope if you could draw the
Oh,
lines.
yeah, probably.
I think that's for negative slope.
Okay.
Odd just means that you could divide it diagonally and it would lay on top of each other. So this one is a neither. And C. Does the function have any extrema? What did we talk about extrema? We've talked about this before. What does extrema mean? Extremes, okay. What would be extremes? Maxes or mins? Does this one have a max or a min? It's got a min at, remember with maxes and mins, we use what value? Y. So where is my min? Y equals 0 at X equals 2. Remember, you have been quizzed and tested on this. Okay? And then D part, how does the graph relate to the basic function y equals x squared? So I'm going to dot in the y equals x squared. All right, there's the parent function y equals x squared. How does this one relate? Tell me the transformation.
Shifted 2 units to the right.
2 units right. Okay. Now, let's look at example 6, and I don't believe y'all have done piecewise functions before. Have any of y'all done piecewise that I don't know about?
college algebra.
Yeah, you did, y'all did, but, okay.
You learn it.
All right, let's talk about piecewise. Now, guys, these are kind of fun, so I need you to pay attention. Piecewise functions, all these are pieces of functions. So this one says, which of the 12 basic functions has the following piecewise definition over separate intervals of its domain? That's a lot, but it's not really hard. So let me show you what you do. So everybody draw me a grid, like that. And I'm gonna color code these, and I'm gonna make this one green, okay? And I'm going to actually make a green marker. So if I had to graph f of x equals x, what would I graph? A straight line through. So I'm gonna dot it in, and so if all you have is your pencil, just dot that in like that. Now, just dot, 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 don't make it solid yet. Because we're gonna make solid the part that we want. Now, this is the piece of it that I want. What piece of this function do I want? I'm going to go to x is 0, which is right here. And what part of this do I want? I want the greater than or equal to 0. So which one of these, the going up to the right or down to the left, is the part that I'm going to make solid? Up and to the right. That's the piece of this function that I want. Does that make sense? So if I can dot in the whole function and then look at the piece that it wants, then that's where I do a little bit better. Now, I'm going to make this one blue. So what is that a graph of? A line with a negative function going through 0. Okay, so dot that in. Now, which part or piece of that does it want? 0. X is less than 0. Where are my x's are less than 0? To the left or to the right? Less than 0? Left. Which part of this function will I solid in? Up and to the left or down and to the right? This part right here. These are all my x's are less than 0. Does that make sense?
So not including 0.
Well, the other one did. So that kind of means that your solid dot overtook your open dot. Okay? So what graph did I create here?
Absolute value.
Absolute value. So that's the answer. All right, now the last one, everybody stay with me because I'm running a little short on time. They give you the graph of the piecewise function. And they want you to write this part. So this one I drew, given the function. This one I've got the graph. So you always start off with f of x equals, and then you draw you a big bracket. Now, how many pieces do you see up here? 2. I see this one, okay, which I'm going to make in green. I'm going to put it right here. And then I see, I'll make this one orange, which I'm going to put right here. So now that you're becoming familiar with the functions, what does it look like this is a piece of? Which function?
The orange one, square.
The green one. We're looking at the green one.
Square.
X squared. Now, which part of it did they want? Were they meeting at what x value? And you always write if x. Which x value are they meeting at? Zero. So I'm gonna put a zero there, but I've gotta determine what my inequality is. So, less than, and we're going, because we want all the negative x values, and we put less than or equal to on the first one. Now, what does this one look like? Square root if x is greater than 0. These never are both equal to. One can be equal, the other is not. It does not matter. Typically, I go with the first one that includes it, the second one doesn't. But I have not found, and I've not been taught a hard and fast rule for that. All right, questions on writing the piecewise functions. Okay, your homework for tonight, turn on the back, very last page. This is going to be partly like your test on Friday, 1 through 12. Do not do 13 through 18 yet. So 1 through 12, you're going to go over these functions and the transformation. So I'm going to give y'all some quick notes, and I know we're running out of time, but write these down. This is it. Remember your transformations. So you might want to write that down. So A is your vertical stretch. If A is greater than 1, it makes it skinnier. A is a vertical shrink. If it's like a proper fraction, like 1/2, 1/3, 2/3, 7/8, and it would make it wider. And if it's negative, that's an NEG. If it's negative, it reflects the x-axis. So this negative x squared gets flipped upside down. Okay. So B's, which I don't think we have a lot of, we don't typically deal with B's. But B is a horizontal stretch if it's between 0 and 1. Use the reciprocal. I don't think you have any of these. It is a shrink if x is greater than 1, but you have to use the reciprocal. And if it's negative, it reflects across the y. Again, I don't think you have any b's to worry about. Now C, if it's x plus c, it shifts to the left. If it's x minus c, it shifts to the right. And if it's D, if it's positive, it goes up, and if it's negative, it goes down. And remember, D is never in your parentheses.
Is he always in parentheses?
C is always in parentheses, yes. All right, I'll leave those up there for just a minute. So see if you can figure out these different graphs